Welcome to Section 8, Lesson 4. The previous lesson factored trinomials with a leading coefficient of 1, where the search was just for two numbers whose product was C and sum was B. When the leading coefficient is bigger than 1, that simple search needs an upgrade. Today's tool is the AC method, sometimes called the split-the-middle method. The AC method takes a trinomial of the form x squared plus bx plus c and looks for two numbers whose product is a times c and whose sum is b. Once those two numbers are in hand, they replace the middle term and the four-term result factors cleanly by grouping. 3 small steps after the initial product is computed. The procedure works for every trinomial with integer coefficients, including those with negative middle terms or negative constants. Sign rules carry through exactly the way they do in the simpler leading coefficient 1 case, just applied to the new product at times c instead of just c. Today's two examples cover the clean positive case and a mixed sign case. The third demonstration shows that pulling out the greatest common factor before applying the AC method always makes the work easier and sometimes makes it unnecessary. Take 3x squared plus 11x plus 6. The leading coefficient is 3, so we will use the AC method. The first computation is the product at times c, and we rid b directly off the middle term. At times c equals 3 times 6 equals 18, b equals 11, so we are searching for two numbers whose product is 18 and whose sum is 11. The candidate pairs of 18 are 1 and 18, 2 and 9, and 3 and 6. Test each one for the sum. 9 times 2 is 18 and 9 plus 2 is 11. Both conditions met. The pair we want is 9 and 2. Use the pair to split the middle term. 11x becomes 9x plus 2x. The trinomial becomes the four-term polynomial 3x squared plus 9x plus 2x plus 6. Factor by grouping. The first pair 3x squared plus 9x has a common factor of 3x, leaving x plus 3. The second pair 2x plus 6 has a common factor of 2, leaving x plus 3. Both pairs left the same binomial, so we pull it out front. The factored form is x plus 3 times 3x plus 2. Factor 6x squared minus 7x minus 5. Both b and c are negative, so the sign reasoning needs care, but the procedure stays exactly the same. Compute a times c. 6 times negative 5 is negative 30, b is negative 7. We need two numbers whose product is negative 30 and whose sum is negative 7. Negative product means opposite signs. Negative sum with a small magnitude means the negative number has the larger absolute value. Test pairs of 30 with mixed signs. Negative 10 and 3 product is negative 30, sum is negative 7. Both conditions match. Split the middle term. Negative 7x becomes negative 10x plus 3x. The trinomial becomes 6x squared minus 10x plus 3x minus 5. Factor by grouping. The first pair 6x squared minus 10x has a common factor of 2x, leaving 3x minus 5. The second pair 3x minus 5 has a common factor of 1, also leaving 3x minus 5. Both pairs share the binomial, and the final form is 3x minus 5 times 2x plus 1. Factor 4x squared plus 14x plus 6. Before reaching for the AC method, check for a GCF. All three coefficients share a factor of 2, so pull that 2 out first. The trinomial becomes 2 times the quantity 2x squared plus 7x plus 3. Now apply the AC method to the simpler trinomial inside the parentheses. A times c equals 2 times 3 equals 6, b equals 7. Find two numbers whose product is 6 and sum is 7. 6 and 1 work 6 times 1 is 6, 6 plus 1 is 7. 7x becomes 6x plus x. The trinomial inside parentheses becomes 2x squared plus 6x plus x plus 3. Factor each pair. 2x squared plus 6x has common factor 2x, leaving x plus 3. The pair x plus 3 has common factor 1, also leaving x plus 3. Pull the shared binomial out x plus 3 times 2x plus 1. Reattach the 2 that we pulled out at the start. The complete factored form is 2 times x plus 3 times 2x plus 1. The GCF stays out front in the final answer. Never let it disappear in the rewriting. 3 takeaways for trinomials with leading coefficient greater than 1. They turn what looks like a harder factoring problem into the same procedure you already know. The AC search is for two numbers whose product is a times C, not just C. The sum still needs to equal B. Compute a times C first, then apply the same factor, pair search you used in the simpler trinomial case. Once the pair is found, use it to split the middle term. The trinomial becomes a 4-term polynomial, and you finish with factoring by grouping from the previous lesson. 2 techniques in series, no new mechanics. Always check for a GCF before starting the AC method. If you can pull a number or a variable out of all 3 terms, do that first. The trinomial inside parentheses will be simpler, the AC product will be smaller, and the search will finish faster.